Every time that music, I got to get that for my ringtone, my alarm. Well, hello, welcome, ASP.NET Community Stand-Up. We are continuing the series. It's the architecture series. It's been a while.
It has been
welcome
a while.
back, David, Damian.
Hey,
I forget. Was it like 6 months or something?
6 months.
It's been a while.
So I just saw you guys at Build in person, crazy, doing your talk and all that. So you guys talked about performance and AOT there. Are you going to be doing something similar here, or?
Yeah, Damian, what are we doing?
No idea.
Yes, slides.
I have some slides from like a different thing about NativeAOT. We're going to talk about NativeAOT more today, I think is the goal. There's some very interesting architectural challenges we had to solve to make ASP.NET Core NativeAOT compatible. Like, and then we'll go into that story after we've gone through the John Loves Community.
Yeah. Speaking of which, I have some links today. You may be surprised. Okay, I got my community links. Doing the share. Here we go. Very exciting. Add to stream. Woo! Okay. So here are the links. This is more high stakes dangerous for me now. We're currently, the URL is, I can't, login is temporarily disabled due to some Twitter craziness. And we're going to be rebuilding it with like GitHub login and some other stuff. In the meantime, I can create them, but they're write only. So if I mess it up, I don't know. It's just, it is what it is.
Living dangerously today.
All right. So the first link, this is the .NET sessions at Build. James put this together. So it's a YouTube playlist, and it's very quick way to get to them all. I'm breaking my low-key rule of not sharing my own stuff and sharing my own stuff, because here's a roundup. This is a kind of a roundup thing that I did. I've been doing these monthly recaps. So this is a 3-minute little recap of May, and it includes a bunch of links. So it was just an easy hack for me to be able to share all my favorite sessions from Build in here. So some of the ones I want to point out, let me see. Oh, that's neat. When you hover over it, something weird happened there. Okay, so I've got, of course, the performance one. I've got the C# and beyond one. C# 12 and beyond is really cool. Also, like, there's the download. Christina Warren does those for GitHub. This is an 8-minute video there. And then there's a link over to Dev Home. You guys set that up, the Windows Dev Home?
I installed it on my personal rig, but I don't have insiders on that, so there's not an awful lot. Like, I really want a dev drive is what I want.
Yeah.
But I need to go back to Windows Insiders to do that, and I haven't done that yet. So, but other than that, I love the concept of Dev Home, and I think as that grows, to have more widgets and support more of the here's my dev machine. Can you like figure out what's installed on it and create me a reconstruction script? And then like save that in my OneDrive, and then when I just go to a new machine and sign in, it goes, "Oh, is this going to be a dev machine?" It just sets it all up. Like once they do that, I'll be on board. That sounds amazing.
I've been doing that for years. I've had like chocolatey scripts, and then I had WinGet scripts and all that, and then you can do a bunch of PowerShell. But it's kind of
so much work.
Yeah, and then this dev drive thing is pretty neat. I talked to Hanselman about it right before he did his like live talk about it, and he's like, this still doesn't work for me, right? But like generally the idea is pretty amazing. It's like a drive that's optimized for fast file access, which is great, right? For Git and for NPM and for all the
all the compilation package restore things. And so like it's like two aspects, right? Like one is that they use ReFS instead of NTFS. And then the other one is they use this new Windows Defender mode. It's like async Defender, where it doesn't do it as much real time. It like batches it up and then does it when it's not busy. So it makes a big difference, apparently.
Damien, I remember you talking about this 5 years or more ago about, right? Like I'm presenting or I'm developing, like back off,
Yeah. Like have a developer button. I think Hanselman has said similar things in the past. Like, you have presentation mode and stuff. I just want like I'm doing development. Can everything get turned off that touches my hard drive and my CPU, please?
Right.
And this is kind of that. Like, if it delivers on that promise, it'll be. I mean, even today, when I set up new machines for folks, or even new on my own, I often forget to go and do the Defender exclusions on my dev folders and my dev processes, and I notice the difference. Like, you absolutely notice the difference, but you can't fully turn off real-time monitoring because security. And so it does make a difference, but it doesn't completely remove it. So I'm super looking forward to being able to try this out.
Cool. All right, let me see. This is a nice walkthrough from Julia, walking through creating a Power App with ASP.NET Web API. And what she's showing here is the Visual Studio stuff. So Visual Studio custom connectors, and then the dev tunnels thing. So, walk through creating the custom connectors and then hooking it up with Power Platform. So it's a really quick little walkthrough, creating the thing and then hooking it up and accessing. So normally when you're creating an API locally on your desktop, of course, it's not going to be accessible for Power Platform development. And so this just makes it really simple to do that sort of stuff. So, this was neat. I saw this come along. This is from the Auth0 team. They created custom templates. I wish more people would do this. So these are just .NET project templates, and so you install them, and then when you here they are, and so it just makes it really quick and easy to create things that are set up for Auth0. So like just general reminder, it's not hard to create these. Like, I've gone through and created custom project templates, and if I can do it, you can do it. So have fun. Source generators, a nice one from Fanny Reinders. Just walking through, this is a kind of hello world with source generators, what they are, how to set them up. So this is.
Can you send that link to me?
This one.
Fowler knows why.
It's pretty on topic for the current.
Like, this is literally the next step in a couple of libraries that I started as part of our NativeAOT work.
Okay.
And I'm like, at some point I have to rip the Band-Aid off and like write my first source generator in my libraries. And I'm like, where's the 5-minute getting started?
I think this is a pretty good getting started. Right. So yeah. And I've heard different things. Like, I've gone through some walkthroughs. It's been a while, honestly, for me. I've heard some varying, like, they're awesome. And then also there's a decent amount of string concatenation. Right, because you're basically now the string literals in recent C# make that easier, but you're basically you're building strings. You're writing code.
Yeah, ish. Yeah, like you maybe there's smart strings because you have compiler context, and there are different ways you can go when it comes to using the Roslyn APIs to generate code. There's super low level APIs, and then there's kind of like the old code DOM code snippet API where you just literally paste huge blocks of code in and just let it figure it out. And I think idiomatic best practice from the team is kind of somewhere in between those. There's a code you build, we went through this on the team ourselves as part of this work, and I think we kind of we ended up being okay with having lots of
and lots of code, to be fair, there's source gen and there's refactorings, and they're different. Yeah. So if you're refactoring, you want to kind of format the text in the documents formatting options. Yeah. Versus source gen could just be a thing that's added because it's mostly invisible. But we still try to preserve the formatting and stuff, so it's similar but different.
Right.
Yeah. Cool. All right. Let me see. This one, kind of speaking of source generators, I saw this an interesting one. This is. Did you see this? So this is a CSV. Parser, and it uses source generators. It also uses generic math and some other
uses all the new hotness, span parsable and span formatable, which I'm big fans of as well.
So and zero allocation and AOT and all the good stuff. Yeah,
all the stuff that if you haven't been paying attention the last 3 releases, you'd be like, I don't know what any of this stuff is.
Right. So he's got, towards the end of this, we've got some benchmarks, scrolling. Yeah, there's a bunch of how he did it and stuff like that. But then the benchmarks, gosh, there we are. Okay. So his library is SEP, which is this one here. And then by comparison, like, yeah, so like,
wow,
you know, definitely faster. I guess Sylvan was the fastest before. So
wow, look at that.
And then he also compares with like readline, but you know, of course, like readline doesn't, like CSV is complicated because you have to escape things and you have to handle some special cases and stuff. So so anyhow, yeah, I'm excited.
It's pretty amazing. Like,
yeah,
I'm hoping that like we see a class of libraries appear in .NET that is like this, so that people that are super experts in performance can make a low-level API, and then the consumers can just consume it like normally, right? For the most part.
Now, question is, some of this stuff takes knowing a lot of stuff. Like you've got to understand
beyond.
What's that?
Beyond, like this is pretty hardcore,
super advanced. Like
it's not even using span, it's like SIMD as well. Like
this is so like all the things. This is using intrinsics. So it's using like a CPU instruction level optimized methods where that stuff leaks into the method name. It's like, oh yeah, I want to use this set of
vector 256, right? Whatever.
The new mathematics stuff. It's using ref structs, which is a new compiler feature that allows you to have types that only exist in the context of a stack, like a call chain. But they're structs, so they don't allocate in the heap, but you can pass them around. They don't copy. And it's using iSpan parsable and iSpan formatter. So obviously it's using span, which is this generic structure that you can apply over different memory-backed data structures, and you get the same API to interact with that, whether it's arrays or native memory or unmanaged memory or whatever it might be. Array pool, which is the new like in-framework way of having a globally shared way of efficiently getting and returning arrays from a global pool. Which is great for when you're working with anything with strings or bytes, because you can do array of char and array of byte and that type of stuff. And all of those things are done so that you can get good performance, low allocation, native AOT compatibility. Like, and source generators obviously it probably shows up in here as well somewhere. So like I said, that's literally everything from like C# 10 and above or 9 and above, which is the last 3 releases. So
John, Control F for link, because he supports for each. But it does not return IEnumerable. It's using the duck type struct pattern for doing enumeration in here, and you can turn it into a link compatible for each. But by default, it will not allocate anything when you do a for each over the rows.
Wow.
So this is like all the tricks pulled out.
Yeah. So question: how much of this stuff can be like? Can you have refactorings and fixers and stuff help you get to this, or is it just you got to be a kick-ass engineer?
I think getting to this from like how we might have traditionally built a library like this with that type of experience is basically impossible. Like there's so much you need to understand. Now, as the consumer, there are already analyzers and refactorings available for framework code in the sense. So if you're consuming APIs and there is a more performant way or a more accurate way to do it, you'll get suggestions on how to do so, and easily just like control dot that stuff. So that stuff kind of already exists. But like, I think this is a whole new area that if you're interested in this, it's stuff you need to learn about. And if you would, like me, had gone a long time not really thinking deeply about how a lot of the runtime stuff works, like in the runtime, how language features map to IL, how that maps to what the JIT does, and then how the runtime manages memory and passes things around and stuff. Like, if you kind of get through your day just ignoring all that stuff, like you go, oh yeah, I read some stuff back in the day, but like I don't really think about it anymore when I code. You can't really ignore that stuff when you're using all this stuff. You really have to understand. The next level is like understanding what the JIT does. We have people on our team who do that. I don't know that stuff. So like people will say, don't do it this way. Do it this way because the JIT knows how to optimize that call pattern. Now that level of kind of like knowledge and optimization is something that the team actively wants to try and reduce, because they want people just to do what comes naturally, and then the JIT, when it's in play, should just be able to optimize all the call patterns where it makes sense. And so often you'll see code reviews where people are like, well, I did this because of the JIT thing, and they'll say, don't do that, go and log an issue on the JIT and the JIT will fix it. So there's a lot more of that going on now, which is great as well.
Okay, cool. All right. Just a few more here. Our good friend Andrew Luck's got one on authenticated cross-origin requests with ASP.NET Core identity. So it is funny. He puts in the spoiler alert at the top. He needed same site none. And then he just kind of walks through like, okay, here, let me move us over to the side again, make some room over there. But so talks about, okay, I've got an authenticated app. ASP.NET does allow me to do a CORS request, handles all that. Now here he tries to go against a different site. It's blocked by CORS. So he says, okay, great. Let's add in CORS support. Nice fancy diagram. Sets it all up. Everything's going to be amazing. And then it's not, because it's not blocked. Here, let me zoom it. It's blocked. It's not blocked, but it doesn't work in that it's unknown. It didn't authenticate the user. So then he needed to go through. I do like how he goes through and kind of actually debugs this and shows, here's what I tried. Here's what was blocked. Showing browser cookies are amazing, or browser dev tools are amazing to show, the cookie usage. So there it was blocked, and then he set same site none, and he's able to get through. So
like Andrew could just print out his blog as a book and sell it.
Well, he does too, right? I mean, like, so he has an amazing book.
But I think this is another great example of just how complicated web programming is.
Yep.
And how, again, same site, if you've never dealt with it, you're like, what is that? Like, what does that got to do with, I've never had to deal with that 20 years ago when I did cookies. CORS is another one that we all like to joke about, just how no one really understands what.
Allow all credentials, allow all headers, allow all.
Then add content security policy, or CSP, on top of this. All the things that the browsers now expose to developers to help control security in their application, and then the things that are on by default that weren't before. And then frameworks like ASP.NET Core utilize those things in some cases to have defaults and then let you turn them on and off. But if you just do a thing and expect it to work, if you don't understand these underlying things, it's super difficult. It is. It's not just ASP.NET. It's anything. It's just hard to do this stuff because there's lots of stuff to know. So it's great when people do
programming. Yeah, it's true. And it's all those headers and all the policies and all the stuff and the caching and it's and then when you're like, why are browsers so awful? And you're reading, it's like, okay, I guess you had to do that because all these other ways people can steal your cookies or stuff.
Yeah.
Well, a little side note, my Amazon account had a cookie get stolen somehow along the way, and things get added to we're getting added to my shopping cart. They weren't getting bought. I changed my password, set up 2-factor auth, still happened. And then I read into this. There's this Reddit thing where it's basically like Amazon's management of cookies, and basically it is a thing in browsers generally, which is not good. Someone steals your cookie.
Yep.
A lot of browsers don't re-authenticate those cookies, and it's basically forever out there.
Yeah.
And I was like, oh, that's wonderful. So then
so this is a common problem with cookie-based session tokens, which is what everyone uses, right? This is just the foundation of how authentication works on the web.
Yep.
And this is how a lot of the high-profile YouTube channels have been brought down, hijacked. Like Linus Tech Tips was one of the recent ones. There's a name for the attack. It's something hijack, something blah 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 blah. But basically through
session hijacking, right?
What's that?
Session hijacking.
Yeah, it's a form of session hijacking. But basically, if you can get something to run on someone's computer, which is the vector is basically always get someone to double click on this exe or this PDF with a vulnerability or something, right? So you email them, and then you get them to run your code. They can just scrape all the cookies out of your browser's temporary storage, right? Because they're doing it as you. It's not elevated, it's not admin or anything. They just take those and they send them somewhere, and then they can easily go and recreate requests using that token. So there's the new thing called channel binding, which is the idea of being able to have a cookie that is bound to the machine the cookie was first sent to, basically, or emitted to, so that even if you take the cookie away and then you try and replay on a different machine, it won't work. Unfortunately, there's no browser standard right now that everyone kind of adheres to that makes that work. You can do super custom things. I think Azure AD has a thing that they have that works with Edge. So if you're using Azure AD based auth, there's a thing you can enable there. But it's an area of problem. And so there are mitigations that the identity provider like Google can do on YouTube, which involves things like what you said, like re-authenticate for important operations. You should always re-authenticate the user. So if they go and try and change the password or delete the channel or like any of these privileged things, you don't rely on that cookie. You force elevation by saying, nope, you need to sign in again. You know, timing out the cookies, obviously, those type of things. Unfortunately, all those things add inconvenience to the user. And so there's always this balance of like, you know, how much inconvenience are we willing to live with in order to get security? But this is a very prominent one right now.
Which makes more sense now when you talk through it, like the kind of pseudo mode that GitHub has you do, right? Where it's actually like you're doing something important, you're all logged in already, but we're going to make you like, we're going to double check.
We're going to double check. Yeah, absolutely. Because then you bring in all the other factors, right? You're not just like this random token that was saying, yes, it means you can do anything. It's like, no, we're going to just forcibly, like just in time verify that you are actually the person that you say you are, that the token says you are.
Yep. Cool.
Anyway, all right. This isn't a session about auth.
I know. Let me go quick here. So Steve Gordon, nice post from here. This is something I had not seen concurrent hosted services in .NET 8. So this is in preview 4, and he's showing this little bit right here. So you can say start concurrently and stop concurrently, and then they can run concurrently. That is really cool.
So for stopping, it's super important because the issue is if you're trying to drain requests and you have other things in the chain that need to stop as well, you all want to tell them to stop at the same time so they can drain, because the grace period waits on all the services. So if one of them kind of takes 5 seconds, the others won't run in the grace period. So you kind of have to say like, I'm going to stop. And then you wait. And then you can end. Before it was linear.
Cool. All right. That is a nice thing. Just a few event things going on. There's this hack together. This is a global hack thing that the Microsoft Teams team has been doing lately. So they've got these events. They've got Amanda. They've got Scott Hanselman. There's stuff going on this week and next week. So that is cool. And then one other thing coming up on the 26th, we have F# Conf. So that's another neat thing. Wanted to let people know about. And then I will stop sharing and I'll turn it over to you folks.
Awesome. So yeah, we wanted to have an opportunity to talk a bit about NativeAOT in more depth in context of aspnetcore and kind of in general, because I think it's going to be new to a lot of our audience, .NET folks, about what that means. And so some of this requires kind of going back and rehashing our basic understanding of what a .NET app is and how does it work, right? And so, and there's a series of blog posts that the .NET team is writing right now about this. And there was one that we did a couple months ago about like why .NET, and went over some of the fundamentals of like what .NET is as a runtime, what advantages it brings, et cetera, et cetera. And so just let's go back to make it really simple. It's like you write code, usually in C#, and then you run that through a compiler as part of your build chain, and that produces IL, right? Intermediate language. It's a bytecode, and you get DLLs out the other side, which contain IL. And then when you run your application, that IL is compiled to machine code using a JIT compiler, a just-in-time compiler that is part of the .NET runtime. And that's done in a fairly complicated way. So it's kind of just in time, so it doesn't compile all the app up front. It kind of compiles the parts of the app that need to be executed as they get executed, and then it can do recompilations as necessary to better optimize the balance between how quickly can I run the code first time versus how can I compile it more to make it faster when I run the code. If that makes sense. You know, how long do I have to wait the latency to get that first time to run versus how fast will it run when I run it? And that's called tiered compilations, like tier 0, tier 1, tier 2. And then there's all these related technologies to do with optimizing that process. So we have things like ready to run, which is this technology that stemmed from something we called cross-gen, and it used to be called NGen back in the day, which was how do I pre-compile parts of my app so it doesn't have to be JITted, because the JIT is a startup cost. Like you have to wait for the machine code to be generated. But then that's a trade-off, like many things, right? Go on.
There's interesting things too that I've picked up lately, like from your talk too, on JIT. There's the startup costs. There's also it's bigger code in a lot of cases, right? Like the actual
well, we haven't got there yet, but yeah. Okay. So one of the advantages of JIT is twofold. One is that it can compile machine code for the machine you run on rather than the machine you compiled on. So you can compile to IL, which is a universally understood byte language. Standard, you ship the IL to every machine, no matter the architecture, the bitness, what generation of CPU it is, with whatever chipset instructions it has. It's all the same IL. And then the JIT compiler can look at your machine and say, oh, like you support these amazing new instructions because you're on the flu blah 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 CPU. Let me compile to that, right? And so your app will run much faster than it would have perhaps even on the machine that was compiled on, because the developer didn't have that, or it was on a build agent or whatever. So there's that aspect. But then there's also the size aspect, which is IL can be more compact than the actual machine generated code because of things like generics. And so like the difference, again, going back to like super basic things like ref types and value types. Ref types, you get like a pointer on the stack that points to a span of memory on the heap. And that's because those objects are typically dynamic in size. They can change size. Like a string is not a fixed size. It can, well, it is actually, because even though it's direct, like you can't change them, they're immutable. But the concept of the string, the type string, can be many different sizes, right? Different instances of strings at different sizes. Whereas when you have
one thing you went through real quick there, but like the idea of generics, like for instance, I have a generic, I don't know, iterator of, and it could be of int or of double or of GUID or whatever, right? But when that's actually compiled to machine code, that actually has to generate you actually have instances.
So that's of course kind of leading up to that. So the understanding the difference between a ref type and a value type from what happens in memory is kind of important to understand why we have this generics case when you have AOT compilation. So in the JIT's case, like you just have the generic type, it's represented in IL. Like that's all you need to worry about. And then they do all the work in the JIT to generate the actual runtime types that fulfill the generic arguments. You have your foo of T1 and T2. Well, at runtime, that T1 and T2 might be lots of different types, right? Like it all depends on how you called that thing. And then the JIT will fill those in, basically generate types for you on the fly. But that changes depending on whether that T argument is a ref type or a value type, because value types have a fixed size and ref types don't. They involve stuff on the heap and stuff that points to stuff on the heap. And so the runtime does different things and the JIT does different things to satisfy that. And so in the case of AOT, if you're pre-compiling everything, you don't have that benefit, right? Like we have to fill in all that generic stuff ahead of time. And so if you've got value types in there, or even in some cases for ref types, the sizes change. And so you might have one generic type, something of T, but then you use that with 20 different T's. Now you've got 20 different types that have to go along with the compiled output, whereas with IL you didn't have to do that. And so there's all these kind of little things that contribute to these trade-offs that occur when we get to native AOT. But we're fast forwarding a little bit.
You also want to mention that with things like engine and cross-gen, the IL and the native code were in the same binary.
Yep.
You were never throwing away the IL. So you always had both the IL and the native code in the same binary. So it was even bigger than like it had to be, right? And that was done for different reasons, like falling back to JIT in some cases.
And then there was kind of like in the .NET framework world, where the framework is always pre-installed on the machine on Windows. Then you have, I'm sure everyone has seen after a Windows update, the .NET runtime optimization service, where they actually pre-JIT the runtime assemblies on your machine. They basically ready to run them or engine them on your machine so that they don't have to ship all the different assembly types, pre-compiled assembly types out to all the different machine types on the planet. Because you can imagine doing that at the scale of Windows. It's like, well, how many different CPU types are there for all the Windows machines in the world? Scores and scores and scores, like hundreds, right? Of different types from the point of view of like what code can it run. And so rather than
the JIT has to have all that logic built in that says
the JIT has the logic for it, but the logic doesn't take up anywhere near as much space as the multiply that out by every piece of IL on the planet, right? Or even just every piece of IL in the .NET framework. And so they actually do that pre-compilation on the machine by running NGen for .NET framework after they've updated .NET framework. And so as Fowler said, you end up with the .NET framework deliverable plus, which is IL, and a bit of native code, plus whatever was natively precompiled on your machine. And then when you do your app, on top of that, you have a small piece of IL, but then you might also run NGen on your app. And that brings along some native code with the IL that you then run on top of this framework that's in Windows. Fast forward to modern .NET, where you can do self-contained deployment. We don't have a machine-wide install all the time. Now you might want to bring the whole runtime with you. And, and this is all before .NET 8, right? We could do self-contained deployments. We could do trimmed deployments. We could do single file deployments. And you could mix and match. You could do ready to run on your application in with or without some of those other things added. And so there was like this quite complex combinatorial matrix of options available to you to turn the various dials available for the different aspects that affect your application size, your application startup time, your application throughput or runtime performance, your application memory use. All of those things are affected by all the other technologies that we just talked about.
And there's also
unfortunately, it's not as simple as just saying make everything as good as it can possibly be. Like that's just the physics of it just don't work that way.
There's also stuff like Blazor WebAssembly too that does the tree shaking and stuff as well.
Right. So then, and everything I've kind of talked about so far has been very much primarily focused on the CLR based tool chain and history. But there's also the mono side of the world, which is what Blazor WebAssembly uses and lots of the Maui stack uses. And while they share a base class library now, the same system.star is used on both the mono runtime and the core CLR runtime. They are still separate runtimes. They share a lot of code, but they also have diverging tool chains for depending on what it is they're targeting. So Blazor WebAssembly has its own native compilation tool chain that it uses. But again, there's shared code and logic between those two.
We end up conflating like things because I guess they're used in conjunction and they're not really pulled apart. So like linking and trimming versus AOT compilation, like they both happen together and like single file as well. You can actually compile your app to native code and not trim and have everything in one big blob. That's possible. But I think what people think of when they think of AOT, they think of like Go, Rust, and C and that class of language. And the thing you end up getting is a small native binary that starts really fast. So a lot of the tech that we use to kind of get that ends up being things that are used together, but in theory aren't coupled, right? You can trim without going native. You can bundle into single file without trimming. And we just have all these options now. And it's really hard to understand like what to choose when. But NativeAOT is a very specific end-to-end story that kind of gives you a C-like experience in .NET. It's kind of what it does.
Yeah, that's a very good point. So we do have a lot of these options already. And people might wonder, why are there 4 options? And like, what combination of those 4 options are supported? And the answer is, it depends. But for NativeAOT, we've very much tried to make this experience. You enable NativeAOT, and you get a set of defaults that is opinionated, which means make the app small, make it start up really fast, and so on and so forth. One thing I wanted to touch on while we're going through some basics and stuff as well to set some groundwork is that the terms native is often used as the opposite of managed. When we talk about native versus managed, the problem is that's completely wrong. So NativeAOT apps are still managed apps. You will still have managed memory. So I think the term managed is best kept when we talk about this stuff for the concept of memory management, where you have a managed runtime is managing memory for you. You don't have to manually allocate memory and then manually clean it up. No, there's a garbage collector that runs. So .NET native AOT apps still contain a GC, right? They are still garbage collected managed memory applications, just like Go is a managed memory application. But unlike C++ and Rust, which are not, they are native and you have to natively manage memory, as well as being native machine code that you compile to ahead of time. So,
and to be fair, Go is also managed. Go has a GC, even though it's
I said that. That's what I said. Yeah. Go is managed. Yeah. So that's a very good point though. Like maybe we just .NET native AOT. Once you run it through, you publish your app, you get your output. What you get is kind of similar to Go in the sense that you have a native code that runs on the CPU that you targeted at compile time, and there's a memory management runtime. There is a managed runtime in your app that takes care of booting your app, understanding types, allocating memory, cleaning up memory, that stuff lives in the application and is still there. So what is not there, and then we're getting we're getting all the way to the really meaty stuff now. What is not there was what makes native AOT super special. There is no JIT. So when you native AOT your application using .NET native AOT, you publish it, get no JIT. There is no JIT in your application at all. And so you're okay. That I get that. It means there's no IL because we native AOT'd it. Okay, so that's good. But there's other things that you may not immediately associate with relying on the JIT. And so, for example, you can't just load an assembly. You can't call assembly.load because there's no JIT to compile the IL into machine code, which is what assemblies are in .NET. They're IL. And so that goes away. There's no concept of loading modules or finding plugins or scanning a folder for assemblies and loading them, or scanning referenced assemblies of the application and finding types in them. That's just gone. You can't do that stuff, right?
So it's kind of all or nothing. The whole thing has to be...
The whole thing has, and this is where we use the term static, which again is a very overloaded term. If you boil it right down to its core meaning, it's the same meaning everywhere. But you need to be able to statically determine at compile time, is this code going to be used? Am I going to run this method? And do I know all the information about the types involved with running that method at compile time? That's what we mean by statically, at compile time, not runtime, not dynamically.
So this also goes into like reflection as well, right?
Yes, exactly. So reflection has two major areas that we mean when we say reflection. One of them is quite well supported in native AOT, and the other one is not supported at all. So the one that is not supported is reflection.emit, because what does reflection.emit emit? It creates IL, right? IL. Yeah. And you can't compile IL without a JIT. And so that doesn't work. But reflection is also used to reflect against what's running. And so you can do discovery and introspection, as I tend to call it, right? So what does that mean? I can look at a type as a type and say, give me all the methods, give me all the properties. And then I can work with them in an abstract way rather than using them as bound members in my C# code. That stuff is supported in native AOT. The challenge is that by default, it doesn't keep members around. It trims everything that it doesn't statically determine that you need. So usually reflection breaks because the trimmer trims all the code away, and then you try and reflect against something that says, I don't know, that you don't have a member called foo anymore, or you try and call a parameterless constructor to do lazy initialization of a type, as I was doing this morning, and it goes, you don't have a constructor on this type. It's like, what do you mean? Like the type is right there. The type exists. How did you? No, I deleted the constructor because I didn't.
So then you can annotate or something, right? You can say, don't trim this.
So that's exactly right. So for things that you can't statically determine based on you calling them in C#, you can add attributes, which is the standard language for adding more metadata in .NET, that the compiler toolchain, the native AOT toolchain, can read to see that you're doing stuff. That you go, oh, okay. So when I see code calling this method, it's attributed saying, oh, that type argument that's being passed in, or this generic argument that's being passed in, I need to keep all the constructors on that. Because even though I can't see that you're calling them, you're telling me that you're going to call them.
Okay.
That works. That works well if the types are statically available. So you can label the types in your application, and the hope is at the very top where it's first called, the compiler sees a static type of foo, type of bar, a generic type in a generic argument. But if you're, for example, assembly.getAllTypes, find type that has the interface foo, if that type is here, do something. All the scanning does not work. So every library that wants to scan for types in your entire app of assemblies, that class of reflection does not work and will not work. And I think that's probably one of the biggest things that you're going to see when people start to use AOT in real life. They'll try to use all the DI containers that love to scan assemblies, all the frameworks that want to scan the entire app to find things. And that's kind of why there's going to be a pivot, we think, in how people build libraries, because that pattern is fundamentally broken with AOT style of apps.
Can you? I can see people being overly defensive and marking everything with the AOT. Don't trim this kind of
right. So that's a very So we should talk at this point about why are we doing this? What is this for? So that people have a better understanding and appreciation of what techniques should they go and do to prepare for the coming AOT apocalypse. So to be very clear, this is an option. This is not, we're not changing .NET to be an AOT like runtime, right? It's not that we're like getting rid of IL and getting rid of JET, not at all. Like AOT is an option because it provides a set of benefits which you have to trade off against a set of not benefits, losses, loss of features and things, and then make that assessment based on the application type. We, for .NET 8, have said in the cloud native API, server API sort of workload type, in that realm, there is certainly some apps that can benefit from native AOT. Those that need to start up very quickly, like very, very quickly from nothing. There is no process running. It's never run before on the machine. And you want to very quickly start the process and have it ready to dequeue something from an event queue or listen to a TCP socket and take HTTP requests or gRPC requests. Like that type of thing that needs to very quickly fire up.
Like a microservice or a worker, that sort of thing.
A worker or a microservice or something in a container that needs to respond to load because you just fire up 5 new instances in a pod because suddenly you get a traffic spike. If you have to wait 5 seconds for those things to to load, you may not get over the spike, right? So those types of situations where the app is sensitive to the startup time can definitely benefit from native AOT. Command line utilities is another one. For similar reasons, like yes, you can benefit from the startup time because you've got a human typing using the command line sometimes. But the other thing is the app size. So getting the published app size down to be as small as possible can be very attractive for command line utilities, right? Where you want someone to just go and download my foo.exe and then just run that at the command line and have it available. If that exe is 80 megabyte, it might hit a little bit different than if that exe is 3 megabytes. And so there's that aspect as well. And then there's obviously, we'll just say it, like competitive landscape. So we, as a platform, when we enter or are marketing ourselves or targeting a certain type of workload, certain type of app type, we are going to be compared to other things that also target those type of app types. So whether that's mobile apps or browser apps with WebAssembly or cloud native apps running in containers, people will ask us, oh, well, yeah, you said you're cloud native now. That's great. But I compared this Go, sample Hello World app to an ASP.NET Core sample Hello World app, put them in a container, and the Go one was 12 megabytes and the ASP.NET Core one was 95 megabytes. Like, what gives? And when I ran them, the ASP.NET Core one used all the memory on the machine, and the Go one used 4 meg, right? And so we have to react to that as a product. And so this is also part of the reason why we're doing that, is for those situations where people might be considering another technology because of the benefits of that technology, just not because it's cool, because that's a whole different set of reasons to compete, right? But because they want what that thing gives them, then we need to address that if we want to be able to compete in those areas. So for all those reasons, .NET 8 is the one where we're like, okay, we're going to target these APIs that run sort of in containers in cloud native scenarios in order to make ASP.NET Core native AOT compatible. And with
those are the cases where, if like you went through a bunch of cases where you want quick startup, small size, all that sort of stuff. There's going to be other cases where it's a bad trade-off, right? Like if I've got a long-running web server, that sort of thing, a desktop app, I don't know, right?
So there's that, but there's also right now the bigger one is like you won't be able to use the features that you want to be able to use. Like because we targeted this first scenario, there's a reason we targeted that first. It's because of the competitive stuff I talked about. It's because of what we thought was technically possible in the time of doing one release, et cetera, et cetera. And we had to kind of learn, like this is in a lot of ways the relearning that we're going through of like, well, how do I build a .NET application given this new set of compatibility requirements using these new technologies available? takes time. Like aspnetcore as a framework is as a thing that calls your code, discovers your code, loads your code, and then calls your code on your behalf. Very much relies on a lot of the reflection type goodness of .NET. And so we had to, in fact, Fowler and I will tell you, like at about August last year, when this kind of first came up, we were like, there's no way we can make aspnetcore work with NativeAOT. Like, it's not possible. There's no way we can make it work.
I spent like a good maybe 3 months trying all kinds of different patterns, trying to figure out what would work, different experiments for things where we have reflection and code generation, trying to find a pattern that would work for like everything.
Yeah.
And we kind of landed on a couple of things, and it required like big changes. And we were like, do we want to do this? Is this really, does it make sense to pull the trigger and try to do it now? Kind of thing.
Well, you didn't want, and the big thing you had in your mind, though, I remember too, was that you didn't want the app code to look fundamentally different. You were like, I'm not inventing a new ASP.NET Core app model. Like we just did minimal.
That was the hard
thing.
Did
minimal with a view towards these type of things. I'm not making people create 4 classes with a bunch of statics, and like I'm just not making them do stuff.
Yep.
It needs to look like an ASP.NET Core app does today. So we need to find a way to make it work with existing app code patterns.
Exactly.
So as you're talking through that, like minimal definitely is like, it's very kind of, it's using statics, and it's very like functional. Whereas the previous, like you've got Razor Pages and MVC and APIs, those are all controller based, and there's a lot more kind of like scanning.
Declarative. Yeah.
Declarative.
Yeah.
So declarative, and then you don't, declarative, and as you said, scanning. So having something in a class and declaring it is one thing, but then not actually hooking that up to program main with a call that the compiler can see. Like that is not how MVC works, right? Like you create a web application builder, you add some services, the compiler can see all that, that's fine. And then you say add controllers, and you give it a string that's like a route pattern. It's not even a route that maps to a specific controller, right? Yeah. You don't call map controller of T and pass it the controller. If you did, it would be a lot easier.
So I have a store controller, and that's declarative, right? I mean, that's like what's
declarative?
It's by a pattern, right? It's and then there's also all the views, right? And so I've got like a store index and a store edit. Those are all just like conventional. That's the word.
It's loosely linked by like strings.
Yeah.
And that's the issue. You basically, the way to think about it is the things that will get trimmed are the things that when you hit F12 on your type to find references, if the results say I can't find a reference, it's going to get trimmed. So like think of it that way. If you can't shift F12 and find all references on the type, it's going to get removed. So you basically have to root the types. It's kind of the term.
And even then, that's not a guarantee, because you can create a whole class hierarchy in your application and shift F12 your life all inside there. But if you don't call into that from program main, they're just going to trim all of it away. No one called it. Why would I keep it, right?
Yeah. Wow. Could source generators do magic?
Yeah. So one of the tools is, so instead of doing runtime based, reflection based, let me find all the things and then generate code or just call them through dynamic invoke, right? Like late bound reflection based invoke. Instead of doing that, which is what we basically do in ASP.NET Core and a lot of the places, let's generate code at compile time using C#, so that all that is part of your code. We started doing that, and that's one of the biggest learning curves we went through. And I'd love to hear Fowler talk a little bit about that. But we still have to solve the last mile, which was we can generate a whole bunch of code, but who's calling it? Like, it's no good if we call it, the framework calls it, because you still have to call web application blah blah blah, and then somewhere in there you have to call the thing that we generated. Otherwise, the trimmer's still just going to get rid of it all. And that was the big insight that Fowler, I think the big breakthrough that Fowler had in some of his prototypes last year. And I'd love for him to talk a little bit about how that led to a new language feature that's being developed right now.
Yeah, so it's funny. I actually wrote this document. Is it still private? I'll show it on the thing. Never before seen.
Oh, wow. An exciting.
Never before seen.
In the secret storage known as Gist? Is that
the
this
secret storage? Let's see. I'm sure this one window. Is that how this works?
It's a document premiere.
Is that
all right? Standing by. So exciting. Here we go.
So this is kind of like I'll say a manifesto. It was setting principles in place to basically figure out how we take what we currently have and not fundamentally change how devs write code to make AOT work. So how do you take your MVC app, your gRPC app, your minimal API app, and have that same app work when you want to do when you want to take it to AOT? And there were a couple of things that we found. So here's kind of like a typical minimal API app, right? So you call map get and you describe the arguments to your method, and the body has some stuff in it. So what happens today in aspnetcore is we take this code and internally it gets rewritten like this. So the method turns into one that takes in the HTTP context, and then we translate each argument to like a binder. And we basically co-generate the code you would have hand-rolled yourself. So for example, int page, we know it comes from query string. We assume it does. Therefore, parse the query string page property. This matches the argument name here. Same for page size. And then this one comes from services. So we know at runtime.
Do you mind zooming in just a little bit more?
Yeah. So we know at runtime every parameter source, and we can generate the optimal code for like every single call. But this happens all at runtime. So how do you take this code and make it work at compile time? Because some of the issues are, this is code that is called in the app, right? The app called map-get. So the app can't we didn't want to fundamentally change how someone had to write this code. Like, how do you make this code as is go from being runtime code generation to being static compile time?
Just to unpack that a little bit, the reason, what we mean by runtime code generation, if you scroll back up, Fowler, that you're calling a method called map-get and you're passing it two arguments, a string and a delegate. It's typed as delegate. Map-get takes delegate.
Any function, essentially.
It's a function, right? And we, the C# language, added a feature for us back in .NET 6 to allow us to take things like typed lambdas. That is a typed lambda, right? Anonymous function right there.
Right.
But it can be basically cast type by the compiler down to delegate, right? So that wasn't supported before. They added that in .NET 6 for us. Then at runtime, just imagine the implementation of map-get looks at the delegate variable that it has, the parameter, and just uses reflection to say, what arguments do you have? What do you return? Do you have a return value? Are you void returning, or are you a func? Oh, you return this value. Great. And we then use link expressions to generate code at runtime, which is what Fowler says code generation. We just mean using system link expressions.
Yep.
And then we call a compile on that, which turns it into IL, which then gets jittered, so that after we've done that once, it's as fast as if you wrote it yourself in VS and then compiled it through C#. Like, it's literally the same speed after that. Okay.
Right.
And so when he says we can generate optimal code, that's what he means, right? Like, we can do a bit of reflection goop. The app starts up, you wait a few milliseconds, and then you get a method that if you'd written it yourself, it's just as fast as that.
And this is why minimal is faster than MVC, not by a little bit, but by a lot, because specifically MVC kind of goes through these layers of abstraction, the binders. And even though those are like super efficient and well written, they just are there's this indirection that you can't get rid of. So we don't short circuit, right? Things
there's a lot of caching and all that sort of stuff, but it still has to happen at some point.
Exactly. Right? So you're going through a binder system, and it has to call through these interfaces and all these things. Minimal APIs basically looks at the function at startup and then says, oh, you're doing these things and you haven't plugged in your own binder for this type. I'm going to emit the super optimized code to parse this thing from the query string and nothing else. So you're basically only paying for things that you extend. So if you want to plug in your own type, it's going to go, okay, you have a type and you have a bind async type on a bind async method on that type. I'm going to generate the code to call your bind async versus the one that's built in. So it really, on a per parameter basis, optimizes the code you would have written yourself. It tries to basically map to the code you would have hand rolled, right? If I'm going to do this by hand, how would I type it in? And it tries to basically get close to that.
Right. If I had written a middleware that manually represented this endpoint, how would I have written that middleware to be as fast as possible? That's how minimal was designed from the beginning. Like, we literally said, let's build a coding pattern that at runtime we can basically write that code for you. so that it is absolutely, you know, pay for play is 100% true. That's what we set out to do.
So I know that there's a lot of like, it looks like MVC. It can do the same things. It's in the same genre of framework, but it literally, you only pay for what you do. That is the main difference. And then one thing that happens here is this basically needs to capture.
Sorry, but this is really helpful because I've talked through, like, I'm explaining. I do talks and I'll explain minimal API, and people say, like, I don't get why saving, like, a lot of people think of minimal as the selling point, right? It's less code. But minimal is not just, it's fewer lines of code. It's minimal, like, in the amount of work it does. It's minimal amount of, like, it reduces that whole pay for play, I think, is the selling point really for a lot, you know, like, okay.
And what's funny is, like, in the very beginning of minimal APIs, like when we started doing implementation for Realties, I spent, like, me and Stefan Halter on the team of engineer, we spent, like, I want to say, like, a month trying to use MVC as the, like, foundation so we could share code. And it became obvious after after that month that, like, there were some fundamental things we have to change in MVC. And what's funny is we actually made a couple of changes, but to get to close the gap, we would have needed to, like, fundamentally change a bunch of the MVC pipeline, which is super extensible, and you can change things per request that you can't really change today. And the stack is great. It's just you can't optimize because of what someone might do. And that issue, like, basically permeates the entire stack. It's not as though that's in one place. It's like filters, binders, like everything in the stack you can mutate per request. And we were like, well, what do we do here? This is, like, too flexible. We can't cache anything. We can't optimize things. We have to allocate these things per request just in case you change it.
Way back, like, MVC is in some ways was inspired way back to, like, Ruby on Rails, which was very conventional, right? It's very kind of magic and conventions and scanning and all that sort of stuff, right? So it's like, it's assumptions and things that go back over 10 years, you know?
Yeah. And I think, like, since we've been around almost, like, 10 years since first prototype of ASP.NET Core, we kind of got a chance to see what the most prevalent patterns were that were being used and what was being extended. And we took all the MVC features and we basically said, like, you basically need 4 of these to kind of build any real app. And then these 2 are nice to haves. And that's how minimal kind of grew from 6 to 7. So it's not as though the feature set is minimal. We're going to end up having a similar feature to MVC, but I think it'll be pay per play. Like, that's one of the core principles. So you will never pay for a thing that you didn't ask for. So I think over time you will see the 2 converging in, like, feature set. Right, but not, like, infinitely extensible. It's kind of the thing that we can't turn on because that disables a bunch of what we want to get from this new API.
Right, and there's parts of, you have to remember, MVC is from pre-ASP.NET Core, from pre-Katana. There was no middleware when we built MVC the first time, and so a lot of the concepts are duplicated, and you don't need to have the concepts in the last part, like the app model part where you create your methods that represent your request handlers. You don't need to have a concept in there if it's already in the server and request handling pipeline part. And so when we build ASP.NET Core, like, I remember very early on, you know, we took what we did in Katana and we used that as a foundation. We looked at Node and other things and tried to build this model. But when it got to, like, you've gotten through the middleware and you need to, like, build an app, like, you need to express endpoints and stuff, MVC is what we had, and we kind of had to build a bridge. We had to bring something across conceptually. Otherwise, like, literally no one would, you'd have to rewrite everything from scratch to get anything to run ASP.NET Core. And so MVC came along basically as a sub framework that was bolted onto ASP.NET Core, even though ASP.NET Core had, like, some features that made MVC stuff somewhat obsolete. And then we had a paper written during .NET Core 3, which was called Project Houdini, which was how do we make MVC disappear? And, and it was like, look at MVC as a framework, as a standalone framework, look at the features in that were attractive, and then pull those out and make them generic features of ASP.NET Core, rather than features that only existed in MVC. So that if you were in middleware or you were writing an alternate web framework like Nancy or fast endpoints or whatever it might be, right? You could still use some of these core things like model binding or whatever it might be. And so that process is a long one. Like that's something that we weren't ever going to do in one release. But that paper is something that we think about when it's like, okay, what's missing? Like what is it that we need to add? And I think we're almost there. Like we added filters in .NET 7. The one thing that people keep asking about is custom model binding. And the problem, I put it in quotes because it means different things to different people. We already support custom model binding or parameter binding in minimal. It's just that it's done in a way that is very new and is somewhat restricted. So you have to have a bind async method. It has to be on the type you're binding to. So you can't just like add a thing to DI, which will dynamically discover per request because of all the reasons Fowler just said. And then like, oh, there's a thing in DI that maps to the T of the thing I'm binding. Let me just like create one of those. And like, we don't do that type of stuff. And so I have a library that does some magic to do some late binding kind of stuff to enable stuff like that. And there are patterns that you can use, but we haven't seen a lot of people adopt those type of things quite yet. And I'll be interested to see as the growth of minimal continues in, how complicated do people kind of get with regards to what they do in that space. And the other one is we don't have built-in validation. So we don't do we don't have an inline validation pipeline like MVC yet.
This is helpful for me to understand. Like sometimes I've got so many like muscle memory things of writing MVC or writing API controllers or whatever. And I'll get frustrated when why do I have to do this? Right. And so some simple things as you're explaining them now, it makes sense. Right. So like design wise, so like, for instance, with an API controller, I liked being able to drop an attribute on the class, or I like being able to DI things into the class. Right. And with a minimal API, I don't have that class to do that with. Right. Now, a lot of that stuff got added back in with groups. So like I can do a group, then I have that ability to work with a bunch of endpoints all at one time, right? So
what's funny is like groups aren't even a minimal API feature. Groups are a routing feature. And we knew we had to do it in .NET 6, but we had to add so many new things to get minimal APIs to even work, like language features, features in the ASP.NET Core. So we kind of, it slipped from the timeline and we did it in 7 instead. But it took some thinking on how to make it work, because groups actually works for everything. MVC, like gRPC, everything under the sun, just that no one knows because it's shown in a minimal API kind of like set, but it's a general feature for routes in general.
That's a good I'll make a note of that, because I occasionally run into things that we only in our blog posts or our samples we show off with minimal because it's the new hotness and it's what we're pushing people towards for a lot of patterns and things. But knowing, like, for instance, a bunch of middleware randomly, like we've shipped some really cool middleware recently, and we only talk about it with minimal. People don't realize, hey, that works just great for Razor Pages or MVC or whatever, right? So.
And that's like intentional. So we basically, it's funny, I had to tell our engineers that write the blogs to show an MVC sample for all the things that we do, because we've been showing minimal APIs since it's the new hotness, but everything we design works with every framework that we design.
Right.
And the big pivot was to make things less MVC features and more pipeline features. So all the new components work in their core pipeline and for everything that supports endpoints, Signaler, MVC. So we basically took MVC and yanked out the idea of endpoints, and now it's hoisted into every framework. So Signaler
routing, right? So we extracted routing in ASP.NET Core 3. This is
3.1, right?
And we called it global routing for a while, but it's routing and endpoints. And MVC changed to, rather than using its own routing, it projects its routes into the pipeline's routes. But that was transparent to most users. And so a lot of people to this day haven't really absorbed the ASP.NET Core's core programming primitives, middleware, routes, middleware, and endpoints. Like that is what you build your app with. It's just that Signaler, Razor Pages, MVC, minimal APIs, they all just produce endpoints. They all add routes, and they all have middleware running. So, your route gets evaluated, middleware then runs, and then an endpoint gets executed. Oh, how does an endpoint get executed? Because there's an endpoint's middleware. So the core fundamental thing is still middleware. Like even routing is still just a middleware.
Yep.
So if you can kind of appreciate how these layers build on top of each other and how we extracted those things from MVC over time, you start to get a much better appreciation, I think, for how can I solve this problem that I just used to do it this way in MVC? It's like, oh, maybe I need to write a middleware that reacts to some endpoint metadata that I attach to the endpoint when I declared it up front. How do I add metadata? Oh, well, there's a common patterns. You either have an attribute or an extension method or both. And then that allows the developer different levels of expressiveness. And then you can just read that stuff at runtime. And so, it's learning that stuff is beneficial. Absolutely. Yeah. And there are some fantastic articles, again, by folks like Andrew Locke, who have written a lot of stuff about since ASP.NET Core 3 about how that stuff works.
It's funny. It's important because it helps you understand how the auth attribute works and why we had to re-engineer it to, even though it's the same attribute, the way it worked before we had before we had it as an endpoints feature, it was an MVC filter. So if you hadn't grokked that change, there's actually an MVC authentication filter.
Yeah.
And it's in the pipeline, and it looks at the attribute, and it does a thing. And then in 3.1, the attribute still was the same to user code, but the way it worked completely changed. It's now based on something in the core pipeline that we can take advantage of in Signaler and gRPC. And that happened out of need because we wanted auth to work the same in all the frameworks. And MVC had been the one that had done the implementation based on the old MVC. And we had to find a way to kind of make it work in a way that was shared across all the platforms. So it's hard to recognize those changes if you're not paying attention to how it works and in the pipeline.
Okay. So question, we've got some questions coming in.
Yeah.
Should we go to questions now? We're at an hour and 15 minutes. So we probably,
yeah, we can ask some. We can answer that.
Okay.
There's one that I think we should answer about reflection that's interesting.
Generating code to replace anything reflection related, a concept that's being considered.
Yeah. I think to answer that question, you can kind of ask yourself this. Do you want a small binary? The answer is no, you can. So you could imagine not trimming anything and just adding more code. You'll get fast startup and big binaries. So you're trading off being able to trim. The only reason to trim is because you don't want to emit native code for everything, right? So you can imagine a world where you just generate, assuming that you're gonna load, you can't load new assemblies, but everything that's in your assembly, don't trim anything and just keep it there. You probably get 100 meg binary because it's gonna blow up in size. But for this specifically, the issue is if you keep everything because someone scanned for all types, if anything in your assembly, if any library called get types on an assembly, first of all, which assembly? Second of all, you basically have to keep everything just in case. So the reason we took a hard stance as to why this code doesn't work well is because you basically would have to keep all the types in the assembly just in case anyone wanted to use them, right? So to make the where work, you would have to be able to analyze the where statement at compile time and figure out that the filter was one that was to make this work properly the way you want it to work. You probably want to say get all types, find all things that are controller based, and keep those. All right, that requires super complex understanding of the expression, which we just don't want to do because it basically requires running the code essentially, right? At compile time. We don't want to do that. So the way to think about it is the alternative for this is you need to source generate the equivalent. You need to, at compile time, discover all the types and then bake those types in somewhere, hard code, here are the things I found. which means you can't add them at runtime. So you can't do plugin loading. You can't do a thing where I have my host app, and I'm loading in plugins from other parts. That doesn't work in this world. It's a different universe.
Now, are there ways to do, like, if you did command line tool, like you actually did during your talk, you did something to like optimize your DB context.
DB context optimize, yeah.
I'd never seen that command before. I felt well, I learned something, but
nice.
Has that been around for a while and I just didn't know?
Yeah, it's been a few
versions, right?
Yeah.
Yeah.
Is there a way that you could basically declaratively say, like, optimize, scan for my controllers?
No.
Okay.
Well, yes and no. So there's a couple
patterns.
There are a couple of patterns. There's a couple of reasons. There's a reason why, for example, the EF core tools, you run them at the command line and then they generate code into your project, right? So migrations is another example of that. And obviously the upfront compile model is another one. Razor used to be a tool that ran during compilation. So you would build, and then there would be a Razor target as part of your build, and it would run a command line tool against your assembly that had just been built by core compile, and then it would produce another assembly with your views in it, right? And then we changed Razor to use source generators when it became available, and we basically shared all that code between the old Razor compiler and the source generator based Razor. And so for that, today, when you build a .razor file in a Blazor app, a source generator is invoked that creates the C# code that then is compiled from that .razor file that then gets compiled into the type that represents that component. And a very similar thing happens for .cshtml. Now, the difference, why is it some things can be a source generator and other things you have to run a tool manually that adds code into your project? And it's nuanced, but there's one basic answer. If the thing that you need to generate code for relies on the runtime behavior of your application, then you can't do that in a source generator, because the source generator doesn't run your app. It only gets to see the code while it's being compiled. EF, you configure EF core in code. You don't give it a config file and tell it what database you're talking to. You have method that says add DB context, use SQL Server, set all these options, right? That's code. So we have to run that code in order to be able to configure, like find the connection string or find the database provider and ask it, that's the big reason, is that if you want to be able to configure it with code, you can't use a source gen, and that code, that configuration will change what would have been generated. You can't use a source generator for it.
If time of day is like Tuesday, generate code 1, otherwise generate code 2. So you basically need to, it's funny, it's why declarative things that are config based and XML based and YAML based, YAML is awful, but anything config based, you can just read at source gen time because it's pretty static and emit stuff. Anything that requires looking at control flow in code, it's hard to do, right? It's like trying to re-implement a compiler, like an entire compiler feature in your source generator. How do you figure out if this if statement is true at compile time, and if it is true, like what do you do? So their strategies, like you follow all branches in your in your code, and you emit all the code. So you don't assume that one will be taken. You just assume all will be taken at some point, and you emit more code. So now you're paying the cost of more code emission because you can't just know at compile time what to do.
Right.
So there's all these interesting things that we found during this experiment. Like and it's funny, a lot of it seems not obvious at first. You're kind of like, okay, well, I have this if here, but in development, I want to enable this thing, but I kind of want the linker to trim it out because it's not used all the time. The linker can't tell if that bool is false or true. So it's like, I'm going to assume it's always true and follow all the branches. And then and if you have code in there that isn't linker friendly, it's like, what are you doing? I can't tell what you're doing. I'm seeing some bad stuff here. Like, get rid of it.
All right.
So there are patterns for dealing with that, but that would require another show. So we should definitely come back, because there's a lot of detail in a lot of these that we can branch off into, a lot of these things, to talk about how we work around a bunch of these things where we can, and then other places where we have to go and change API design. Like
Jason is probably one of the biggest.
Jason, we had to create a slim builder versus a normal builder, which is unfortunate, but there's reasons. And MPG SQL's doing a similar thing. So there are the design patterns kind of limit you. So
All right. Well, let's go through a few more questions here. Okay. Let me know if any jump out to you as ones you definitely want to do. Otherwise, I'll just...
So people are asking, like, is AOT supported in Maui and other things and stuff, or Blazor server? Like, so the answer is right now in ASP.NET Core, at least, we're making the core pipeline, the server, the middleware, all that stuff we're trying to make work, and minimal APIs, right? So we've built a source generator for minimal APIs, right? That's so when you turn on a native AOT compilation in your project file, then we enable this source generator so that we don't use the runtime code generation, we use the source generator. And there's a few things that the source generator doesn't support, some sort of edge cases that the runtime one does, but for generally speaking, it's basically a good fidelity match. But then beyond that, nothing else is in scope in .NET 8. So, you know, SignalR or Razor Pages or MVC or Blazor Server or any of the other like large chunky mini frameworks. It's only minimal APIs and gRPC that are supported in .NET 8. But we are definitely looking to add support for more things in subsequent versions. It's just a matter of time.
Yeah.
And then for other stacks like Maui, WPF, WinForms, Maui has its own native AOT based tool chain depending on where you're compiling to, because the Maui app can run on Windows or iOS or iPad or Android or so like it depends. It's totally different technology depending on where you're running, and they have native toolchain support for lots of the target platforms. WPF and WinForms don't have that right now. There's no plan to do that that I'm aware of right now. But if you're interested, you should totally log those issues on the repos and express that interest.
Cool. Okay, another quick one here. Was Feather related to minimal APIs?
Yeah, so Feather was the pre-experiment that we had. It was kind of a customer development research thing to get an impression of how people thought about .NET. So we made Feather, and we ran a bunch of experiments on customers. Experiments sounds super crazily. We're like giving them kind of poison, but we showed customers minimal APIs and asked them what they thought. We asked customers what they thought about .NET before showing them Feather. And then we showed them Feather, and then we asked the same question afterwards. And there was a lot of like, is this .NET? Is this C#? This is weird. I looked at JavaScript kind of feedback. And we kind of turned that into minimal APIs. But Feather did not have the same set of features like the binding to delegates. We had to go and take Feather and kind of like add language features and a whole bunch of other features to make it actually look like what it is today. I'm pretty happy where we landed. I love kind of how the framework looks, and kind of it's funny. There's a lot of I watch a lot of YouTube videos on people like talking about APIs, and the comments are always like, just use controllers. And I think that's fine. I love how the comments are always about how it looks like Node.js, and like to me, it just looks like lambdas. But the thing that we do really well is we support this like binding of parameters, and that is magical. Like the only other framework I've seen do that is Rust. One of their frameworks does a similar thing, but like that is magical. Being able to just say int page and get the thing bound from the query string or route, that to me feels very like a nice advantage of a typed language. So it looks like Node because you're calling map get on a class, but like the C# thing there is that the thing has strong types, right? So that actually feels nice to me.
Cool. Okay, some quick ones here. So is there a code sample, or is this something where you basically it just magically AOTs your?
So there's a new template. Part of this was we needed to create a new API template. So again, .NET 8, we're focusing on cloud native, container deployed API applications using minimal API. So we created a new template. So it's called the API application template rather than the web API, which is the existing one, which lets you pick controllers or minimal. And the API template has a checkbox, or if you're in the command line, you can pass --AOT, and it will generate you an API sample app, as templates do, that is ready to go, publish AOT. So when you publish it, it works. You get a native AOT app. It's about 10 megabytes on Windows, and it works. And you don't get any warnings or anything like that, which the native AOT toolchain will give you if it finds something that's like, this probably isn't going to work. So I just need to tell you that was the focus of doing so. So that I would start there, go and create either if you're in ASP.NET Core, go and create a new API app and tick the box that says publish AOT. If you're just interested in AOT and .NET in general, the console app template has also been updated to support native AOT on creation, as has the gRPC template. So you can create a new gRPC project, tick the native AOT compilation there, and you can see how the app changes. Create two, create one with it and one without, and then look at the code difference. There is a little bit of code difference. Most of it is to do with JSON, as Fowler alluded to before. The serializers are a notoriously complicated and tricky part of ahead of time compilation.
Reflection.
Because because of this whole aggressive trimming thing that we talked about. If serializers don't run in your code, it's something that kind of the compiler can't see, right? And so
it's actually really it's a really hard problem. Like if you break it down, all the obvious things that you want to do are insanely complex the moment you want to trim away stuff to make your binary small. So I think that's a whole topic. I think we could go super deep on that.
Yeah,
it'd be fun to talk about.
All right, I'll take a few more here. Also from Peter here. You alluded to this, that you do get some errors. I mean, if I have something that won't AOT well, what's my experience?
Yeah, so the dev experience is like this. So whether you're doing trimming and/or AOT, you put a property in your project file. So there's a publish AOT. You set that to true. And what that does at dev time is it enables a set of analyzers. Two sets of analyzers gets enabled. There's a set of trimming analyzers and a set of AOT analyzers. And they work together to find places in your code that you've written in your projects, that you're calling an API that has been annotated via one of these attributes that we mentioned earlier, that relies on a feature that is not compatible with NativeAOT. And there's a series of these attributes that you can use to say, hey, this method, if you call this, it requires unreferenced code, or it requires code generation, or it requires something else. And so if the analyzer sees that, you'll get a warning in the editor, like a squiggle, right? And a thing. Then in addition to that, when you publish your application, the native AOT toolchain, the IL linker or the IL compiler, it runs full analysis, not just of your code, but all the code. Any code that it determines that isn't going to get linked away or trimmed away, it runs all the analysis over at an IL level. And it will tell you if it finds any code that's being kept that is problematic from a native AOT point of view, and you'll get a warning. And then if you want to see the details of those warnings, you can set another property to say, hey, don't just roll up and say, this library that I'm using has AOT warnings. Can you expand that out and show me all those warnings? And you can do that. But that's not generally what we expect. What typically will happen is that .NET libraries, including the .NET framework itself, ASP.NET Core and the .NET base class library, they have to go through a process of being annotated for native AOT friendliness. And then what happens is a bit gets set in their assemblies, and all their APIs are annotated with all of these attributes so that the compiler and the analyzer knows what methods are safe for AOT and what ones basically aren't, right?
Okay.
And so if you're calling stuff that hasn't been annotated, you won't get analyzer warnings, but you will get the warnings when you publish. And if you're calling one that has been annotated, you will get warnings during development time when you try and call a method that is annotated as not supporting native AOT, if that makes sense. So there is going to be a process for the .NET community, for the NuGet community, to go through and update their libraries where they utilize some of these features that are not compatible, to mark them as friendly or not, and to go through and annotate the APIs.
Okay.
Yeah. Cool. And to be fair, like when you get the warning in the library that you don't control,
yeah,
kind of when you're in like no man's land, because you can't. Yeah. It's a binary. It's compiled already, and we're looking in the binary to make sure that the things that you're calling are AOT friendly, and it's probably not. And once you see the warning, you're kind of in like maybe it works land, and then you file issues, or you like ask nicely. Like don't go bombard every third party library author to go be like, I want support for this stuff right now. It's a process. It's taken us a while to figure out how to get patterns for making various parts of the platform itself work. So I imagine this is a multi-year effort, starting like from 7 to like whatever version will be like. Yeah, now we can like AOT a normal app that uses EF, like even EF does not work. So just as an example, right? Like our stuff isn't fully done yet. So
yeah, in your demo, Damian, you used a special like data access.
Yeah, I created a new nano ORM called Nanorm, which is basically tries to do a dapper like database access library, right? Like map this and query this with T, and you give it your SQL query. And but it's designed to be native AOT friendly, so it doesn't and low allocation, all that type of stuff. So it's very early days, but yeah, I built that to just try and help, you know, move the needle forward a bit.
Cool. All right. So I'll do 2 last questions, both of which are kind of a what's next thing, sort of. How do you know what's supported in AOT? Is there a doc?
For ASP.NET Core, there's a doc. So we have a doc in ASP.NET Core. It was mentioned in the Preview 3 blog post. You can probably just search for it and find it very easily. And it lists as a table of the major areas of ASP.NET Core and their compatibility with native AOT. From Preview 5 of 8.0 onwards, we also annotated the top level methods for adding services for those areas. So if you try and call like services.add controllers and you've set up your project for native AOT, you'll get a warning. It says, nope, add controllers requires something that doesn't work in native AOT. Okay. So that's kind of the place to start. Now, again, I want to reiterate, for .NET 8, we didn't set out expecting or doing this with the intention that a large proportion of apps would move to native AOT. Absolutely not. We don't know exactly what percentage. Like we threw about a few numbers internally, like maybe 10% of apps or something like that. And that's really where we're looking for feedback from customers. To how appealing is this? How, you know, with regards to the compatibility of restrictions, like how much of a problem is that for the type of apps that we're talking about? What are the most, you know, important areas that you would need us to go and do the work to support native AOT in for you to be able to use it? That type of feedback is really critical for us. But please don't think that because we're talking about this in .NET 8 that we're expecting everyone to go off and try and enable native AOT. It definitely does not work everywhere yet.
You can try it, it won't work.
Yeah. Well, and a good place to start is with those templates that are the most supported scenarios.
The ones that say they have a tick box that says, yeah, make this native AOT compatible. Exactly.
Cool. Okay, last question here then is, where can I read more and the upcoming changes?
So we did a blog post in Preview 3, I think it was. It did a bunch of overview on that. There are some docs. There's also the foundational .NET docs with .NET with native AOT. So there's some good docs there about the process you go through as a library author to make your library trimmer friendly, and also what does native AOT, you know, the restrictions of native AOT and those type of things. Some docs about that. So I'd recommend reading that. And then between now and .NET 8 GA at the end of the year, we'll produce more content, obviously, for folks to go off and read. But we encourage folks to try it out. Like, you know, install the preview, create one of these apps, and you know, using one of these templates we talked about, and, you know, play around.
Cool. All right. I included you search for .NET 8 Preview 3, and there's a bunch of stuff in there. So very cool. All right. I look forward to having you guys back on and go deeper on this.
Yeah, it'd be great.
I learned a ton, and I really do understand now some of the design point things that explain minimal and explain how, understanding why things are changing, why my cheese moved, it makes it a little more helpful. So very cool.
Yeah, that's good to know.
Awesome. Okay, well, I'll wrap up here, and I'll schedule another show coming soon.
Great. Thank you.
All right.
Thanks.
Talk to you later.
Bye.
Bye.